All right, so I'm going to try to finish up oxidation reduction today. The next unit we're heading into is transition metals. So in the last class, we were talking about delta E knots of cells, so the standard potential of a particular electrochemical cell. And as we ended class last time, you had a clicker question, which you told me what the reaction was at the anode and the reaction at the cathode for this particular electrochemical cell. So now we're going to calculate what this delta E naught is for this cell. So we have an equation that we can use to calculate delta E naught of a cell, and that is that the delta E, or the potential of the cell, is equal to the standard reduction potential for the reaction that's occurring at the cathode minus the standard reduction potential for the reaction that's occurring at the anode. So you told me which reaction was occurring at the anode and which at the cathode last time. So we can just go ahead and use that information in here. So the reaction that's occurring at the cathode is the copper reaction, and the reaction at the anode is the zinc reaction. And note here I have these written as reduction potentials because we're going to be plugging in the standard reduction potential into this equation. So where do we get our standard reduction potentials? Well, your textbook has tables of many standard reduction potentials. And of course, on an exam, you would be given that information. And the standard reduction potentials are measured against the standard hydrogen electrode. So we talked last time about what some of these abbreviations mean. So we can look up the values, and they're all going to be listed as reduction reactions because they are standard reduction potentials. So all the reactions, if you're looking for ones written as oxidation, you'll be out of luck. They'll all be written as reductions. So here, written as a reduction, zinc plus 2 electrons to zinc solid, copper plus 2 electrons to copper solid, and you can look up those standard reduction potentials. And then you can plug them in to your equation. Again, the equation is the standard reduction potential for the couple at the cathode, the standard minus the standard reduction potential for the reaction at the anode. So the reaction at the cathode is the copper reaction, and so we put in here 0.3402, and then minus, and the zinc reduction potential is negative, so it's minus 0.7628, and then if we add that together, we get a positive value of 1.103. And so in doing these, this is a pretty easy thing to do, but I'm sort of emphasizing it because a lot of people out-clever themselves in doing this. They say, well, one's an oxidation one thing is being oxidized in this reaction, one thing's being reduced. So I'm looking up a standard reduction potential. I'm going to change the sign and then plug it in and change the sign again. And so they change the sign so many times and they come up with the wrong answer. So just a hint in doing these problems, if you always think that the equation is asking you for the standard reduction potential, look that value up and put it in. Don't do anything fancy with signs. Just use this equation as written, plugging in the standard reduction potentials, and you'll be all set. And you won't have any problems getting it wrong. So try not to out-clever yourself and flip signs around many, many times in doing these problems. All right, so we have a positive value then for our potential for the cell. So we can ask the question, in this type of cell, would the flow of electrons be spontaneous? What tells us if something is spontaneous? Delta G tells us if something is going to be spontaneous. And we mentioned last time a connection between delta G and delta E. So delta G tells us if something will be spontaneous, and we talked last time of this equation that delta G naught for the cell is equal to minus n here being moles of electrons, times Faraday's constant, times the delta E naught for the cell. So here, again, we're relating back to thermodynamics, back to delta G, and we're thinking about whether things are going to be spontaneous or not. So if we have a positive value for delta E naught of the cell, what's going to be true then for delta G? It'll be negative, and so will it be spontaneous? Yes. So if delta E naught is positive, delta G will be negative, and if delta G is negative, the reaction will in fact be spontaneous. So the answer then is yes.